this next section, 6.8, is applications, word problems. So quadratic word problems. And as usual, generally the hardest part is translating a problem from a word problem to a math problem. I sometimes skip that step to some extent. For number 19, they have a triangle with a height of h and a base of b. And the area is 1/2 height times base. That's because you can fit it inside a rectangle, h by b, with area hb, and the triangle is half the area of the inscribed circumscribed rectangle. Okay, so as a general rule, area equals 1/2 h times b. In this particular case, the area is 15 square centimeters, and the height is base minus 1 centimeter. And the question is, what's the height? What's the base? Okay, so we start with this, put in 15 for area, 8b minus 1 for h, and get the equation 1/2 b times b minus 1 is 15. All right, that's the hard part, translating to math. Now, okay, to solve this, first let's get rid of this 1/2 by multiplying both sides by 2. Get b times b minus 1 equals 30. So b squared minus b is 30. So b squared minus b minus 30 is 0. There's your quadratic. And to factor it, we need p and q equal to -1, their sum equal to -1, and their product -30. And long story short, -6/5 does it. So we can rewrite this as b minus 6 times b plus 5 equals 0. So therefore b equals 6. Hi, kitty. Could you hear that? Here's a vocal one. Or b is -5. Now, -5 doesn't work because we're dealing with actual lengths, and we don't talk about negative lengths. So b6 is a solution. H is 6 minus 1, or 5. So it's a 6 centimeter base and a 5 centimeter height. Oh, dear. Now, for the number 21, they had a picture, okay, and in nice, expensive 4-color printing to improve the price of the book. But it shows a sailboat, the luff and the lift, whatever. There's a height, there's a b and h. Area is 1/2 b times h. Area is 24 square feet. The b is 3 times h. And what are these? Well, it's easy enough. All right, 1/2 b, that's 3h, times h equals the area of 24. And then multiplying throughout by 2, you get 3h squared equals 48. So h squared equals 48 over 3. So h squared equals 16. And then to solve this by factoring, we transpose the 16. H squared minus 16 equals 0. This is a difference of squares. H squared minus 4 squared. And that's difference times sum. H minus 4 times h plus 4 equals 0. If this is 0, then h is 4. If h plus 4 is 0, then h is -4. Negative lengths don't work, so we throw that out. So h is 4, b is 3 minus is 3 times 4, which is 12. So this is 12 by 4. Here, it's actually kind of silly to actually put it in terms of a quadratic formula. X and y are positive integers. Y is 2 more than x plus 2. Their product is 143. What's x and what's y? And really, if you try and solve it by quadratics, then you wind up going through the same trial and error process that you might as well do just by plugging in values for x and y. And 11 and 13 work fine, and that's all you really need to know for this one. Like I say, I could have turned this into, let's see, x times x plus 2 equals 143, so x squared plus 2x minus 143 is 0, blah, blah, blah. I wind up going through the same search process as this, so it's not really that clever. Now here we have a right angle triangle, And the rules for a right angle triangle is that this side squared plus this side squared equals this side squared. This is 6 yards tall and 8 yards long. And here's a cord between the top of this pole and this peg in the ground. And how long is it? All right, Pythagoras says a squared plus b squared equals c squared. So in this case, d squared equals 6 squared plus 8 squared. So that comes to d squared equals 36 plus 64. This adds to 100 is 10 squared. And then transpose the 10, d squared minus 10 squared equals 0. So d minus 10 times d plus 10 is 0. So either d is 10 or d is negative 10. Negative numbers don't work because we're dealing with lengths. So this positive solution works. The distance is 10 feet. Here we have a picture of somebody jumping on in the book they have a picture of somebody jumping on a motorcycle over a ramp. Big deal. What's salient is that this diagonal is 17 feet. And this base is 15 feet. So what's this height x? Well, x squared plus 15 squared equals 17 squared. That's the Pythagorean theorem again. So x squared equals 17 squared minus 15 squared. That's 289 minus 225. And that comes out to 49. X squared equals 49. That's the same as 7 squared. We transpose x squared minus 7 squared equals 0. So x minus 7 times x plus 7 is 0. If x minus 7 is 0, then x is 7. If x plus 7 is 0, then x is negative 7. We throw out the negative values, so the distance x is 7 feet. That concludes that part. Let's see. One more. Well, this is something about the rows of in a triangular array and how many dots are in all those rows. And the formula is 1/2 r times r plus 1. When is it equal to 36? For what value of r? Oh, when I put a semicolon here, that's not a mathematical expression. That's punctuation. Statement, semicolon, question. So given this, all right, what is r? All right. Okay. To solve this, first we transpose the 2. R times r plus 1 equals 36 times 2. And let's distribute, you get r squared plus r equals 72. So r squared plus r minus 72 equals 0. We need numbers p and q whose sum is the 1 coefficient here. And whose product is negative 72. And long story short, negative 8 and 9 work. So r minus 8 times r plus 9 equals 0. So either r minus 8 is 0, so r is 8, or r plus 9 is 0, and r is negative 9. Negative 9 is not a solution that makes sense in this word problem. So r is 8, and it's 8 rows deep, this triangular array. Excuse me. First things first. That. I do believe we're done with this. So let's stop recording.